In this video, we're now going to show the cofactor expansion to find the determinant of matrix B. In the previous video, we have shown that through the cofactor expansion theorem of Pierre-Simon de Laplace, we can actually find the determinant by expanding through the cofactors of any row or any column. And we have selected this specific column because the rest are zero. So if it's multiplied to 0, we're not going to look for any other cofactors except for 3 multiplied to its cofactor. Now, let's now expand this one. So, the cofactor at the first row, third column, so first row, third column, would mean that we'll have negative 1 raised to 1 plus 3 multiplied to the minor of the first row, third column, which we know is the determinant of this submatrix. We'll have negative 1, 1, 2, 0, 2, 3, 0, 2, 3, and 3, 4, negative 2. Which will now bring us to finding again the determinant using cofactor expansion. So, since we have a 0 here, it's better for us to choose this column. I'll use color blue ink. It's better for us to choose this column because it has a 0, meaning we'll only need to compute for the cofactors of 2 of the entries. So that would mean, so another sub-solution, the determinant of this submatrix would be equal to negative 1 multiplied to its cofactor. 0 multiplied to its cofactor is 0 plus 3 multiplied to its cofactor. So there we go. And now, so to look for C sub 1, 1, C sub 1, 1, that's actually negative 1 raised to 1 plus 1. This is C sub 1, 1. This one here, C sub 1, 1. There you go. We need to look for the determinant of the other submatrix 2, 3, 4, negative 2, which will give us here negative 1 squared. And this one will be 2 times negative 2 minus 3 times 4. And bringing that panel up, there you go. We'll have here negative 1 squared, then this becomes 4. Negative 4, that's 2 times negative 2, minus 12. Therefore, here, we're going to have, this is just positive 1, so whatever this is okay. This becomes negative 16. So there we go. Now, for C sub 3, 1, let's carefully remove this one. There you go, and the 0 was also erased. So there. Now, we want to find C sub 3, 1, so we remove the third row, first column. So therefore, this is negative 1 raised to 3 plus 1 multiplied to the matrix, to the determinant of the submatrix 1, 2, 2, 3. There you go. And then, this will now become negative 1 raised to 3 plus 1 multiplied by 1 times 3 minus 2 times 2. This is negative 1 raised to the 4th power. Well, this becomes 3 minus 4. And this becomes now negative 1 raised to 4 is positive 1 times negative 1 is, well, negative 1. Now we have these numbers. We can now go back up here, which will actually give us, it's a negative 1 times negative 16 plus 3 times negative 1, 3 times negative 1, and that will actually give us positive 13. So that means the number I'm looking for here is 13. Don't have space, so I'll bring this down here, that my C sub 1, 3 is actually equal to negative 1, 1 plus 3 is 4, multiplied to this number 13. And since this is negative 1 raised to 4 makes this positive, C sub 1, 3 here becomes positive 13. Therefore, the determinant of B is actually equal to, oops, let's not place that just yet here. There you go. That would be 3 is equal times C sub 1, 3. Its cofactor, which is 3 times 13, making it 39. Therefore, the determinant of B is 39. So even though this solution is quite long, we have saved ourselves much more time because we were choosing rows or columns that have zeros in them, making it for us easier to cancel out and only perform some computations. And that is an example of cofactor expansion.